Good morning to one and all present here. I am Mr. Muthu from second year AMLA going to talk about 8086 architecture. The 8086 microprocessor is a 16-bit microprocessor developed by Intel in 1978. It has a rich architecture and its instruction sets are capable of handling various addressing modes, making it versatile for programming tasks. And now I am going to explain about how 8086 microprocessor is divided into many functional groups. The 8086 microprocessor is divided into two main functional groups. One is bus interface unit and another one is execution unit. The bus interface unit fetches instructions and reads data from memory and input-output ports and writes data to memory and input-output ports. The execution unit it executes instructions that have been received from the bus interface unit. Okay, basically the bus interface unit. The word bus means we all know the word bus means traveling from one place to another. Same happens here. The bus helps in transfer of information from one place to another, and in the execution phase, the information getting from the bus interface unit is taken and it is being executed properly. Okay, in bus interface unit, there are many subunits such as register, segment register, and instruction queue. Registers Registers are like pointers that we use in C programming languages. Registers uh, helps to store the value of address of the given variable, or instructions. Okay. So while we are accessing the register, it contains the address of the value that we need to access. And using that address, the value is being accessed. Okay. Segment register in bus interface unit. Segment register uses four segments and registers to access different sections of memory. Okay, and that will be explained in the later on systems. Instruction queue. Prefetches instruction to speed up execution by using a 6-byte instruction queue. Okay, now we will go to the execution unit. Okay, the instruction that is fetched by that has come from the bus interface unit is being fetched by the execution unit and it starts executing. Remember one thing, the BIU, that is bus interface unit, and the execution unit function separately and they do not cooperate into parallel processing. Okay. In execution unit, the processes that would be executing are arithmetic and logical unit. Arithmetic operations like addition, subtraction would be taking place. In logical unit, logical gate operations such as AND or bitwise operators would be taking place. Now, Pranav Shakti will be explaining about this.
Good morning to one and all present here. My name is Pranav Shakti S from class AMLC. Today I'm going to talk about function blocks. Understanding functional blocks. Functional blocks are distinct components in the system that perform specific functions or processes. They are often used in engineering, computer science, and system design to modelize complex systems, making them easy to understand, develop, and manage. Each functional block typically has defined inputs and outputs, allowing to interact with other blocks of the system effectively. Importance of function blocks. By breaking down a system into smaller manageable parts, function blocks allow for easier design implementation, maintenance, reusability. Function blocks can often be reused in different projects or systems, saving time and resources. Simplification. Complex systems can be overwhelming. Function blocks simplify the design process by focusing on specific tasks, making it easy to understand the overall system. Scalability. Systems built with function blocks can be scaled more easily. Bus system. A bus system in computer architecture refers to a communication pathway that connects various components of a computer, allowing them to transfer data, addresses, and control signals. Here are the key aspects of bus systems. Types of buses. Data bus transfers actual data between components. The width of data bus is example for 8-bit, 16-bit, and 32-bit. It determines how much data can be transmitted simultaneously. Address bus. It carries the addresses of the data so the CPU can access specific memory locations. Control bus carries control signals from the CPU to other components, coordinating operations like reading or writing data. There are two types of bus architecture: single bus architecture, or all combination common bus, dual or multiple bus architecture. Use multiple bus to reduce congestion and increase throughput, allowing different components to communicate simultaneously. Types of function blocks: input and output blocks. Input blocks represent entry points for external data or signal into the system, indicating the flow of information. Conversely, output blocks signify points where the system transmits data or signals to the external environment. Processing blocks. At the core of system functionality, processing blocks encapsulate functions that manipulate or transform incoming data. They serve as hubs for computation, transformation, or operation critical to the system overall functionality. Control blocks exert authority over information from within the system, regulating and managing the execution of functions. Automation of bus systems, it's cost effective, its scalability can be added much more easily, and it is shared resource. Disadvantages of bus system, bandwidth limitation, complexity and control. Overall, bus systems are a fundamental aspect of computer architecture, facilitating communication between the CPU, memory, and peripheral devices. Thank you to all for watching.